Hi everyone, this is your last video for distance and midpoint. I'm going to do some midpoint example problems for you in this video. This one hopefully will be a little shorter than some of the other ones because I think I only have 4 practice problems for you in this one. All right, so let's go ahead and jump into it. So my first 2 questions are just simple midpoint problem. So I'm going to do the first one and then I'm going to have you pause the video and try the second one on your own. Okay, so this first question asks, determine the coordinates of the midpoint of a segment with endpoints 316 and 7, -6. So like all distance and midpoint problems, I'm going to pick one point to be point number 1 and the second point to be point number 2. And then I'm going to plug those values into my formula. So remember, I am finding xm, ym, right, the midpoint, which is x1 plus x2 all over 2, comma, y1 plus y2 all over 2. Okay, remember, key for this one is that you're adding your endpoints, not subtracting them. Okay, so let's plug our numbers in. So I have 3 plus 7 divided by 2, comma, 16 plus -6 over 2. Let's make that look more like a 2. All right, now I need to add and divide. So I have 3 plus 7 is 10. So 10 divided by 2, comma, 16 plus -6 is the same as 16 minus 6. So that is 10 divided by 2. And since I can divide those, I'm going to go ahead and do that. So I get 5. So that is my midpoint. When you are asked to find a midpoint, this is what your answers will look like. Okay, it will be a coordinate point. It will be a location in space. All right, so I want you to see if you can figure out the next one. For this one, I only gave you a picture, not coordinate points. So you have to figure out what the coordinate points are for point E and point D before you can plug them into the midpoint formula. All right, so give that a try and then check back in a second to see if you got the answer correct. All right, y'all, so go ahead and check your answers against mine. So I found my 2 coordinate points were -3, +3, and then +3, -1. So I plugged those values into my midpoint formula. So I have -3 plus 3 divided by 2. I chose this to be point number 1 and this to be point number 2. Then for y's, I have 3 plus -1 divided by 2. -3 plus 3 is 0, divided by 2 is 0. And then 3 plus -1 is 2, divided by 2 is 1. And if you look on the actual drawing, if you go to plot that point 0, 1, that point is right here. So it is on the line. And if you look, it is exactly in the middle between point D and point E. All right, I have 2 more problems for you, but I need to pause the video quickly to clear my screen. So give me 1 sec. I'm going to do that, and then I will see you back for the last 2 problems. All right, y'all, so here we are for the last 2 problems in this video. The first one is mostly midpoint, but then we're going to do a little distance review also in the second one, all right? So let's take a look at this one. This says, a segment has endpoints with these coordinates, a, 2b, and -3, +4b. So this question says, write the coordinates of the midpoint, so I'm still talking about midpoint formula, in terms of a and b, meaning that my answer will not be a coordinate point with numbers, it will be a coordinate point with a and b in it. All right, so we're going to have to combine some like terms here and use our knowledge of algebra to help us out on this one. Okay, so I'm going to call this one point number 1 and this one point number 2. All right, and I'm going to plug those into my midpoint formula. So I have x1 is a plus x2 is -3a divided by 2, comma, y1 is 2b plus y2 is 4b divided by 2. All right, so first thing I need to do is combine my like terms, which I can do because I have a and a here for x. All right, so I have a minus 3a is -2a divided by 2. comma, and then 2b plus 4b is 6b divided by 2, and then both -2 and 6 are divisible by 2. So I'm going to go ahead and divide those. So I end up with -1a, and normally when it's a 1 in front, we just drop it and say -a, comma, 6 divided by 2 is 3, so you have 3b. Okay, so I know this looks different than a traditional midpoint, but it is a midpoint in terms of a and b. All right, so last one, let's look at number 9. This one definitely is it's a slightly different type of problem because they give you some different information. So they say C is the midpoint, okay, and they give you C. They tell you that C is the midpoint. So this right here, the 5, 0, is the midpoint. Okay, so that point is XM, YM. Right? And then they only give you one of the other coordinate points. They only give you one of the endpoints. So this, oops, I totally drew that in the wrong spot. Okay, so this right here, 2, 4, is one of my endpoints. Okay, so let's go ahead and label these how we normally would. So if this point A is an endpoint, that's like x1 and y1. Okay, and point C is the midpoint, which means this isn't x2 and y2, it's xm and ym. Okay, so we're going to have to do some solving and we're going to have to work backwards a little bit. Okay, so remember, you have your midpoint formula is xm, ym equals x1 plus x2 over 2, comma, y1 plus y2, sorry, that doesn't look like a 1, over 2, okay? And so remember that what that actually means is that xm is equal to this, right? Xm is equal to this formula right here, and ym is equal to this formula right here. Okay, so really what we're doing is we're doing xm equals x1 plus x2 over 2, right? So really this is what we're doing. Xm equals x1 plus x2 divided by 2, okay? And ym equals y1 plus y2 over 2. Okay, so let's plug the values that we know into these two equations right here. So I know that xm is 5, so I have 5 equals, x1 is 2, plus, I don't know what x2 is, divided by 2, right? So I can now go through and solve this for x2, right? So remember, whenever you're solving, you're always working from the outside in. So the first thing that's in my way is this divided by 2. So to cancel it out, I'm going to do times 2 on both sides. Okay, so I have 10 equals, that's going to cancel that out right there. 10 equals 2 plus x2, right? And then I need to subtract. Let's change this color actually to that. I'm going to do -2 and -2 on both sides. So I end up with x2 is equal to 8. All right, so that's my x coordinate of point B. All right, and then we're going to do the same thing for y. Okay, so for y, I know that ym is 0. So 0 equals 4 plus y2 divided by 2, right? And I'm going to go through all of the steps here, but you could just get rid of the divided by 2 technically, right? Because you just want to know in the numerator what's going to make the numerator equal to 0, right? But I'm going to go through the steps. So I'm going to say I need to cancel the divided by 2 out. So I'm going to do times 2. So I have 0 equals 4 plus y2. And then I need to subtract 4 from both sides, minus 4, minus 4. So you get that y2 is equal to negative 4. So when I put those together, I get that B is the point 8, negative 4. Okay? All right. So that's kind of like a working backwards type problem for midpoint. And then we're going to use that information that we have now to figure out part B and part C. So these, see, they say, what is AB and what is BC? Remember that whenever you see something that looks like this, what they are talking about here is a distance. Okay? When they just tell you the two endpoints, with no line or line segment or anything like that over the top of it, they want to know the distance. So we need to use the distance formula here, okay? So we have AB, okay? So we're going to use point A and point B here in the distance formula, okay? So remember, my 2 points are A is 2 comma 4, and B is 8 comma negative 4. All right, so let's plug those into the distance formula. So just for my own ease, I'm actually going to call this one point number 2, because those are the ones that I usually plug in first, right? Because it's x2 and y2 minus x1, y1. So I'm going to call this point number 2 and point number 1. But again, you can do it the opposite way. Call this first one 1 and this one 2. It does not actually matter. Okay. So I'm going to go ahead and plug that information in. So I have x2 minus x1 is 2 minus 8 squared plus, right, and then y2 minus y1 is 4 minus negative 4 squared. Right, so let's go through our process here. So we have d equals the square root of 2 minus 8 is negative 6 squared plus 4 minus negative 4 is positive 8, right? Because I have 2 minus signs right next to each other, right? So those become plus signs, right? And then I need to square both of those values. So negative 6 squared is 36. Remember, any number squared is positive. 8 squared is 64. If I add those together, I get that d equals the square root of 100. And 100 is a perfect square number. So the square root of 100 is 10. All right. So that is the distance from point A to point B. Now, if we look at part C, it says, what is BC? So you could do this 2 different ways. You could plug the values, you could plug points B and C into the distance formula and go through the exact same process that we did in part B, but I think there is a simpler way, because remember, C is the midpoint of AB. Okay, if it's the midpoint, whoops, hold on. Let me erase that. I'm going to do this a slightly different way so that I can do some typing. Okay, so remember, if C is a midpoint, then that means that AC and BC are both half the distance of AB, right? So, and I'm hoping you guys kind of remember that from last week, right? Remember, if you have when you're dealing with like segment addition, right? If you have AB is your line, okay, and C is the midpoint, if you know the whole thing is 16, for example, then each of these parts would have to be 8, right? Because it's half. This idea for distance applies whether or not the line segment is straight horizontal like this, if it's vertical, if it's slanted, it doesn't matter, right? I could draw the same line segment slanted like this. So here's like A, B, like on a coordinate grid, and here's C. if you know that this distance is 16, this slanted distance is 16, that means these two individual slanted distances are both 8, no matter what, right? So if AB, which is the whole thing, is 10, then that means BC is 1/2 of AB. So that means BC is 1/2 of 10, which is 5. Right? Much easier than using the distance formula a second time. But you can use the distance formula if you use points C and B, and you would get the exact same answer. All right, everybody, so that is it for this midpoint practice problems video. You have now, once you're watching this one, you've reached the end of the videos for this section. Please let me know if you have any questions, and I'll help you out with whatever questions you have. I'll see y'all on the next one. Bye, everybody.